All right. Statement question. Question number 12. You throw a baseball straight up. What happened to the work done by gravitational force, the sign of that? So when it on the way up, displacement is up and the gravitational force is down. So then in the opposite direction, the work done will be negative. The work done by the gravitational force will be negative. On the way down, displacement is down, force is also down. On the way down, the work done by the gravitational force will be positive. So the correct answer is B, which says work is negative on the way up and positive on the way down. Number 13. So you can see that chapter 5 questions are relatively easy compared to chapter 4 questions. There's no vectors or scalars. You need to know the formulas. Well, the formulas are given in the formula sheet. It's a basic, straightforward question. We have what is the work done by a constant force. We apply a constant force and push this box, and the box is being get a displacement which is d. The displacement direction is this way. The force is at an angle of theta degrees to the horizontal. So the horizontal is the displacement direction. So the work done by this force will be F cosine theta into the displacement. This is the equation for the work done, which is in the formula sheet. Okay, no harm memorizing it. Then you substitute. F is equal to 20 Newton. Good. Cosine. Angle is the angle between the displacement and the force, which is this, which is given to us as 50 degrees. Substitute. Multiply by delta x. Delta x is 3 meters. Substitute. Take your calculator, work it out. You should get this answer. Done. Easy, straightforward. Every exam you'll get this same question. So you already know the answer to your midterm 2 questions ahead of time. Of course, it won't be the same numbers. Okay, so the same question though. Number 14. Another straightforward question. Chapter 5, what we learn after we learn the work done by a constant force, we learn what is the kinetic energy. So you need to remember the equation for kinetic energy. Even if you forget, you can just quickly look up the formula sheet and you will see it is equal to half mv squared. So this question giving us the mass, giving us the velocity, substitute, you get the kinetic energy. Straightforward question. Okay, just substitute and get the answer. Plug and chuck. M is 50 kilogram and V is 3.4 squared. You should get this answer. Done. See how easy it is, right? Right. So, I can, for example, instead of asking you to calculate the kinetic energy, I may give the kinetic energy and I may give the mass, for example, and ask you to find the speed. Okay, so not an issue, right? We can rearrange it to make the speed as the subject and calculate it. Or you can use your calculator in the solving mode just to ask the calculator to solve for the unknown. Okay, why did it? Okay, number 15. Now comes a theorem, because we define what is kinetic energy, what we define how to get the work done. Then we have a theorem that we learn in chapter 5, which is, anyone can tell me what that is? Yeah. If you do some work, all the work that you do will go into change the kinetic energy. So there's a relationship between the work done and the kinetic energy. If you do some work, what happens? It will go on to change its kinetic energy. This has a name. This is the work kinetic energy theorem. Right, so this is the one that we are going to use to answer this question. Read the question. A 2 kilogram box sitting on a smooth table is at rest at position x 5 meters, so x equal to 5 meters, its velocity is 0. Then someone is pushing it starting from 0 speed because he constantly applied the same force and keep pushing it and comes to this position 9.2 meters. The question is, what is the speed when it reaches this x equal to 9.0 meters? Now it is the time to apply our theorem, which tells you if you do some work using this force, calculate the work done by that force that is equal to the change in the kinetic energy. So of course this is the net work, but here there are other forces that will do work, but they are all vertical forces. The displacement is horizontal, so the only work will be the work done by this applied force of 5 Newton. The other forces will do zero work. So the work done will be, from that force, it will be F cosine 0, right? Because the angle between the force, because we are applying the force horizontally, multiplied by the displacement, this is the force, the work done by that force, equal to change in the kinetic energy. We will write half m v final squared minus v initial squared. That will be the change in the kinetic energy. And all you have to do is to now substitute whatever is given, and the question is to find the final velocity, the final speed rather, which is the unknown here. So that's what we have to find. Let me substitute values. F is equal to 5 Newton, and this is cosine 0 is 1. Delta x is equal to, tell me what is delta x. Is it 5 or is it 9? 9 minus 5. Okay. Because that's a catch here, okay, 9 minus 5. Delta x equal to half. Mass is equal to 2 kilogram. Final velocity is unknown. Initial velocity is 0. That's it. You know, you can do simple algebra and bring Vf as the subject and calculate Vf. Or, you know, you can, if you like, you can go to your calculator and use it in the solving mode and get the answer. So let me do it. Let me show it to you. 5 multiplied by 9 subtract 5. Well, you can say, okay, I know 9 minus 5 is 4, but anyway, let me just do everything. Equals alpha calc, that will bring the equal. Half. You can use this fraction to write the, you can also, you know, you can just put 0.5, that's also okay. But anyway, let me do it this way. Multiply by mass of the object, which is 2 kilogram, multiply by, you start a bracket. Then here, this is the unknown. Vf is, excuse me, come to the front, please. Excuse me, stand up. Yes, come to the front. Now, front, first row. So you call it x. So that is the unknown we need to find, 0 squared. You don't have to do that, but anyway, so squared. You can just leave it out because it's 0. Right, that's it. Just to make sure the equation is correct, you know, you didn't make any mistake. So this is fine on the left-hand side, right-hand side is fine. Then shift, calc. This is not the answer, right? You know, this is what was stored in the x from previous calculation. You press the equal button again, that will give you the answer, 4.47. So to two significant figures, it will be 4.5. Good. Let's move to question number 16. This is a question, one of my favorite questions, comes again and again. That's a possibility it comes in again. So this question says, in a problem using energy consideration, you know, the equation has change in the potential energy, okay? Change in the potential energy does not depend on where you put the y equal to 0, the reference level. So the answer to this question is C, which says it does not matter since only differences in the potential energy, I mean change in the potential energy matters in the solution. So it completely irrelevant where you put the y equal to 0. The answer will be the same no matter where you put the y equal to 0. So that's why C is the correct answer here. Question number 17. Sarah pushes a 5.9 kilogram crate up a ramp 30 meter in length and inclined at 10 degrees with the horizontal. What potential energy change does the crate experience? So now, after we introduce the potential energy, we are now ready to apply our work energy equation, which is modified for the system, which in the most general form you can write like this. So we are not assuming anything. There may be, if the system is not isolated, we may have some external work done by external forces. If there are some non-conservative force which cannot be, rephrased or made into a potential energy, so there will be a work done by non-conservative force is equal to changes in its kinetic energy and the potential energy. So our question here is a box being pushed, a crate being pushed by someone. So you have here, he is only asking just the potential energy change. So we don't have to bring in the energy equation, we just the definition question. So I was bringing it unnecessarily, but anyway, this is the figure for the question. This is being pushed. A distance of height delta y, we don't know, but he is giving us this delta x, which is 30 meters, and this angle theta, which is 10 degrees. So changing the potential energy, simply the definition. We need all, we have everything we need. M is given, G is given. Delta y is not given straight away, but we can calculate it. M is equal to how much? 5.9. G is, of course, the magnitude of the gravitational acceleration. Delta y, see, delta y is not given, but along the ramp, this distance is given. You have to remember your trigonometry. It will not be given in the formula sheet. Now, what involves here for this angle, the delta y is what we need to find. It is not given. Delta x is given, and the angle is given. So you just immediately recognize we have to go for the sine theta, because sine theta is equal to opposite, which is our delta y, divided by hypotenuse, which is our delta x. So I can immediately see that delta y is equal to delta x sine theta. Okay?
No sine inverse?
Huh?
Sine inverse.
No. We need delta y, right? We don't need, theta is given. So instead of delta y, I can write the delta y in terms of what is given. 30 sine theta is equal to 10. That's it. So this is a definition question again, okay? It's not, no, we don't bring in the energy equation. That's what I thought initially. So just bring in the energy equation, substitute the values and calculate. You will get the answer to be 300 joule. Delta y is positive because the object is going up. Right, next. Number 18. Now this one, we need our energy equation, because what we have here is a roller coaster which is rolling down. It has some velocity at this point. So V initial, it has a velocity of 12 meters per second. By somehow maybe roll down from a height, and by the time it comes here, it already has some velocity. There's no engine or anything. It is pulled up somewhere, then let it fall down. Then it will get some kinetic energy from the lost potential energy. So at this point, it has this much of velocity, speed. Then when it comes to this point, there is no friction in the roller coaster. What is the velocity at this point? This is the question. And we have been given the height at point A and the height at point B. How do I do this? We have to go to the energy equation, which is work done by any external force multiplied by work done by a non-conservative force is equal to change in the kinetic energy plus change in the potential energy. So this is what we are going to use to solve this problem. Okay, our system, because now we are involving forces as change in the potential energy, they are conservative forces. So our system consists of the roller coaster, the coaster, and the track, and the earth. For this system, we don't have any external force, isolated system. So this goes to 0. And we say there's no friction, so that also goes to 0. And so we have 0 plus 0 equal to change in the kinetic energy. I can write half m v final squared minus v initial squared. And the change in the potential energy, I can write mg delta y. Okay, good. Right, then we go 0, just 0, equal, I don't want to repeat the same thing, okay, fine. Can you see that? Okay, let me repeat. Half, m is what? We don't know m. V final, again we don't know. V initial we know, which is 12. Plus m we don't know. G, 9.8. And delta y is 5 minus 3. Is that right? Final y coordinate minus initial y coordinate. Oh, minus 2. Thank you. Minus 2. We don't know m. Is that a problem? Can I do this? 0 multiplied by anything is still 0. So I can do that. Now I take my red pen. We have these 3 terms on either side of this equation. And m is the common factor in all that equation. So m get cancelled. Okay. So our equation becomes 0 equal to half v final squared minus 12 squared plus 9.8 multiplied by 5 minus 2 is 3. Let me keep it as 5 minus 2. Right, now you take your calculator. And just type the equation and ask it to solve for the V final. So 0 equals, you can use this fraction or you can even put 0.5 for half. Multiply, V final is our unknown, you are going to call it x squared, don't forget the squared, minus 12 squared, close the bracket, plus 9.8 multiplied by 5 minus 2, close the bracket. You know what to do now. Shift, calc, that's not the answer, you should see the L minus R, press the equal button now, that's give the answer, 9.2. L minus R, that means you know it has checked its own calculation and found it to be true, verifying the answer. So C is the answer. 19. Similar question, but now we need to bring in the full equation again. Don't assume anything until you read the question and confirm. So this, I can just write it without any problem. That is valid, most general equation. It doesn't assume it is isolated. Now let me look at this system. We have a block which is 5 kilograms. This is pushed up on a ramp, and it is moved by a force, an external force. Okay, it is not part of our system. What is our system? Our system is the block, the ramp, plus the earth. So this force, external force. So we do have this. It is not zero. It's not an isolated system. I cannot include, this may be a person who is pulling it, or a motor or rope. So that cannot be made into the part of the system, so it stays outside the system. So we have an external force to the system which is doing work. And there is a friction as well. That means this guy also not zero. There is W and C. Equal to change in the kinetic energy plus the potential energy. So let me come here and expand that. So W by external force is the work done by that applied force, F cosine theta delta x. Okay, I will do the substitute in the next step. Work done by a non-conservative force. It is a question. He's asking us to find the work done by the non-conservative force. Not just the force, but the work done by the non-conservative force. So I will just leave it like that because we need to find this whole thing. You raise your hand and ask me. What is your question? Right, equals change in the kinetic energy half m v final. What is the velocity when it is here? This is the initial, so v final minus v initial squared. Change in the potential energy mg delta y. All right, now let me expand this. Start here. F is equal to, can you tell me, someone tell me? 42. Yeah, right. And theta is 0. F is horizontal. The displacement is also along the ramp. Not F is not horizontal. F is parallel to the ramp. Delta x is also parallel to them. Same direction. Delta x and F is in the same direction. So theta is equal to 0. Cosine 0 is 1. So I don't have to worry about that. Delta x, how much it is? 2 meters. Okay. Plus, this is our unknown. We are asked to find that. Half m is equal to 5 kilogram and v final, it says constant velocity, and he says therefore this is the same as this. V final is equal to V initial. So what will it make it? It will be equal to, delta K will be equal to 0. This whole thing, this is equal to this. That means this part will be 0. So 0 plus m is equal to 5 kilogram and 9.8. And what we need is this height. Again, our trigonometry. We can see that delta y is equal to delta x sine this angle theta, which is 37. So I can substitute here delta x is equal to 2 meters. So 2 sine 37. That's it. We need our equation with only one unknown. We just put it in your calculator and solve for our W and C. (42) multiplied by 2 plus, I will call it x, because that's the unknown we need to find, equals 5 multiplied by 9.8 multiplied by 2 sine 37. Okay, then you solve it and you will get the answer. I didn't close this. I forgot the multiplication. Probably it doesn't matter, but just to be on the safe side. Okay. Right, shift, calc, equal button, we get the answer. 925. I'm sorry? Yeah, yeah. You have to do shift and calc, then you have to press the equal button. Okay, you have to. Yeah, but it is, there is a 42 plus, there is this, see, there is a x. No, you can do the algebra if you want, it's okay. If you don't want to use the calculator in the solving mode, you can say x is equal to 42 multiplied by 2 minus 5 into 9.8 into 2 sine 37. Then you don't need to use the calc. That is doing the algebra, right? Yeah, fine, it is perfect, okay? So I'm just telling you, if you hate algebra, I hope you don't, right? You just write it in a calculator and use the shift calc and yeah.
What happened to a cosine theta?
Cosine? Ah, yeah, 0, right? Theta equal to 0. Cosine 0 is 1. Yeah, I didn't put it because theta equal to 0, not cosine theta. Cosine 0 is equal to 1. If you want, you can put it in the calculator. But right, so this is a statement question. So here we have a spring hanging, the block is hanging on a spring. So we will have both potential, gravitational potential energy change as well as elastic potential energy change. So it's a statement question, the answer is B. The system has both potential, gravitational potential energy change and elastic potential energy change, okay? So, right, this question, it looks a bit scary, but it is not. If you, all you have to do is to use the energy equation. Again, you write it in full form. In fact, this potential energy has two forms, right? Two different potential energy changes. So potential energy gravity, change in the potential energy elastic or the spring. So we have a spring here. The question is, we have a block which is released from rest, so it will have a 0 velocity and comes down, gather velocity, speed, and there's a spring here. It will hit the spring with some velocity speed, because you gain speed by the time it comes to, then it will compress the spring by a certain amount, which is given to us. What we don't know is how high the block was released. We have to find this h. How do we do this? Just use the energy equation and substitute values and see if some h will be an unknown in that equation, the only unknown, and we can solve for it. So this time, our system will be the block plus the ramp, or what do you call this? Slide, okay, slope or slide, okay, whatever, and the earth. We don't have any external force because the block is released from rest. There is no force acting on it. There is no external force, so that means no work done by external force, that is 0. And it says there is no friction in the ramp, we call it ramp, okay, the ramp and the flow, the whole thing together. So that means this is also 0. Please, if you are in my class, excuse me, come here please. Yes, then we substitute for this, changing the kinetic energy. What about the change in the kinetic energy? Only the block will have kinetic energy. Spring is light spring, so they say the no mass. When initially, what is the kinetic energy of the block? What is the speed? We release it from rest, 0. When it is touching this, full compression. Not the final is when it is compressed the spring to the maximum. At that moment, the speed will be reduced to 0. So let's solve this. So we got the system has no external force, so this is 0, and there are no friction, no non-conservative forces, that is also 0. Now, our initial is when the block is here, 0 speed. Final is when the block is compressed to the maximum. Again, the speed is 0. So that will make it, okay, let me write it here, 0 plus 0, that is for these two guys, equal to change in the kinetic energy will be half m, whatever that is, 0 squared minus 0 squared. Final speed is 0, initial speed is also 0. So the whole thing is 0. Change in the potential energy will be mg delta y. Okay, change in the potential energy delta y. I'll do the substitution in the next step. So let me keep it like that. And change in the, this is a gravitational potential. Spring potential energy will be half k x final squared minus x initial squared. Right. Now I can substitute. This is 0. Half m is 0.05. Do I need to bother with this? Because the whole thing is 0.
Yeah.
Okay. Plus m is 0.05. G is 9.8. Delta y is this h, right? Which is a question. Find the h. So h is the magnitude of delta y, but I better put the negative h. But h is the magnitude, okay? So since it is going down, it will be negative of the h. Delta y will be negative h plus half. K is equal to 2100 and x final is 0.022. Initially, it is unstretched to 0 square. That's it. We have our equation with only one unknown, which is h. All you do is to take your calculator and then type the write the equation in your calculator. 0 equals, you have to put the 0 because that's only 0, only digit in the left hand side, okay, 0 equal to this 0, you don't have to put it, okay, so ignore that. 0.05 multiplied by 9.8 multiplied by this step, we have to be careful because not 9.8 subtract h, right? It is 9.8 multiplied by negative of the h. So you better start a bracket. So start the bracket, use this negative, okay? So 9.8 multiplied by negative x. Yeah.
Does it make a difference if I use the minus?
Probably not if you put the bracket. But if you don't put the bracket, it will be a problem. Okay. K is multiplication sign. Oops. Multiply 2100. Okay, it's good to use this, it will save time, you will less likely to make mistake, but provided you practice it. Okay, you do it on your own and you are confident you know how to use the calculator. It's a good skill that you should learn, okay? So please don't do it just before the exam. No, you just practice, do questions using this calculator in the equation solving mode. Multiply 0.0. I don't need the bracket because this one is 0, so I will just put 0.022 square. I just took a shortcut there. I hope you understand that, because the other. Right, now I can solve it. shift calc. That's not the answer. This is what was in the previous calculation. Press the equal button. There you get the answer, 1.0. Okay. You got it?
No.
Why?
No, I got it.
You got it? Okay.
Exact same answer.
Maybe you made something, you mistyped something.
Maybe, yeah.
Check it. Check it. Make sure you got it. Okay.
If it counts to solid, but people doesn't get the answer.
Can I check? Show me the equation you wrote. Zero 0.022, right? Yeah. Okay. 0 equal to 0 plus 0.05. Is that the mass? Here. Multiply by 9.8, multiply by negative x, multiply by 0.5. This is the problem. See, look.
0.5, yeah, 1.2.
You don't have the plus sign, right? What do you have after that? Plus, you forgot the plus 0.5.
Okay.
Okay. Yeah, that's why I'm telling you, okay, it is good to use the calculator, but you better practice, don't make this silly mistake that will take your time and so you should be confident, then it's really a lifesaver. It's time, yeah, inshallah. Okay, right, let me move on. Yeah. We'll go back to the, yeah. Yeah?
When do you consider the net charge and the external force as zero?
Work done, you mean? Work done.
So is it only because
All right. First, you get your system. Your system is the block, the ramp, and the spring, and the earth. Okay, that is a system. So in this system, gravitational force is inside the system. It is coming from the earth on the block. So it is not an external force. Spring also part of the system. Spring force is also part of the system. It is not an external force. Right. That means it's an isolated system. There is no force from outside. That means this is zero. Do you remember the question we did before? There was someone is pulling it. That is not part of the system. So there the external work is there. It is not zero. Here it is zero. Now this guy, do we have any non-conservative force? No. The question says a frictionless. If there is friction or air resist anything like that, it is a non-conservative force. It cannot be translated into a potential energy. Right? So that's the question he asked, right?
But even if we don't get it, we can just see in the question, right?
Yeah, look at the section. You see anyone is pulling or pushing, then there is an external
Is
force.
it frictionless or like in the
Frictionless means this is zero. Air resistance, friction.
delta P is zero, so we can assume that both of them are zero. In the previous question it was given, right?
Delta P.
That is the initial is equal to the final.
Yeah, but why are you bringing that? We are only talking about these terms, right? All right. Don't mix things. Okay, let's focus on the question you asked. You're asking about why this is zero. Okay. Right. This one. The last question in this. So you have someone climbing a mountain. This is the last topic, the power. Power is the rate at which you are doing work or the energy conversion, because now what happened, whatever the work you do will be spent in changing your potential energy, because we are assuming it's 100% efficient. The work you do is just to move you from ground, bring it to the top of the mountain. Potential energy change. So there's no kinetic energy change because you are moving with the same speed or you are going at the zero speed. That we can assume. So all the work done is just to change the potential energy. So the work done will be changing the potential energy. Divide by the time will give you the power. The question is to find the power. That's it. Substitute and get the answer. M is equal to 60 kilogram. G is equal to 9.8. Delta Y is the height of the mountain is 370. All I need is the height. because the change in the y coordinate, right? Just the height. So it is positive because it's going up, not coming down. So 370 divided by the time. Time is given as 50 minutes, but we need SI unit. So you convert the minutes to second and you calculate, you will get the right answer. Okay. Right. So that finishes uh, this past paper.
Like 60 by 50.
Yeah, it's 50 minutes, right? You divide by time. But minutes is not SI unit. Second is the SI unit. So you have to convert the minutes because the answer is in SI unit. This W mean what? Joule per second.